What's up, guys? Welcome back to another video on Double A Learning. Today we're gonna be reviewing a geometry or trig topic, and it's gonna be special triangles. So before we get into the special triangles and explaining what special triangles are, we need to know a few basic things about triangles. So the first one is that all angles of a triangle add up to 180 degrees. Okay, so this should be like a fundamental thing you guys should know and associate with triangles. Let's just say we have a triangle right here. All the angles here, here, and here have to add up to a total of 180. So x, x, x. So that means x plus x plus x have to all equal 180 degrees. Okay, so the next thing is that I'll get a new sheet here. The next thing you guys need to know is that there are many different types of triangles. Okay, so this is another key thing you guys need to know about triangles. So some examples of that can be like isosceles triangles or right triangles. And actually, right triangles is what we're gonna specifically focus on for special triangles. So let's focus on right triangles really quick. Okay. So right triangles. Okay, so right triangles. Let me draw how they look. So this is an example of how one right triangle would look. So in this right triangle, we see that this leg right here and this leg right here. Oh, by the way, the triangle has two components. This is a leg. These two are legs, and this longer side is known as the hypotenuse. So in right triangles, the two legs of the triangle come together to form a right angle right here. And if we actually had multiple triangles, like 4 of them right here, we'd form another right angle here, and say we had another triangle right here, and then once more. You guys can see that we'd have 4 right angles, and that would be a total of 360 degrees, and that creates a square, like a tilted square, I guess. So yeah, so that's the feature of right triangles. So what you guys need to know is this one special special triangle, and right triangle is a 45, 45, 90 right special triangle. Okay, so what this means is that there's a 90-degree angle and two 45-degree angles, and we can kind of solve this here. So we see that these two angles right here, they're about the same length of each other. So let's denote this as x and denote this one as x. And we need to remember our fundamental property, I guess, that all angles in a triangle add up to 180. So I'm just gonna write that 180 here on the side. Okay, so we can kind of create an equation to solve for these values of x. Even though we know this is 45, 40, and 90, we can create a equation, because if we were told hey, these two sides are equal, we'd be like, okay, we'd either know right away it's 45, 45, 90, or we can just try to solve for it. So what we would do is do x plus that 90 degrees that we know, because the two legs cross, and yeah, and that forms a 90-degree angle, and that's equal to 180. And that 180 is adding up all the angles. So what we can do is this x plus x turns into 2x, and this 90 subtracts to this side, so that's equal to 90. And this is just simple algebra. X is equal to 45. So now we can know that both these values here are 45 degrees. And if we add 45 plus 90, we get 180. So that's a 45, 45, 90 triangle. And this triangle actually also has a special component besides both the angles being the same. Their sides are unique as well. So the two legs of the 45, 45, 90 triangle, this leg right here, that is across this 45, across one of the 45s is going to be denoted as x. And then the one across the other 45 is also going to be denoted as x. But the one across the 90-degree angle, if you just draw an arrow like this, is going to be denoted as x root 2. So this can be really helpful if we're given just one side, like say if this was like 2 and we had to find the hypotenuse. Well, we know that the both the legs are both equal to x. Then we just plug x into the hypotenuse equation here, and then we know the hypotenuse is 2 root 2. So this is a fundamental rule you guys have to memorize for like a trig class, or if you're taking the SAT. This is important to know for the geometry section. And yeah, so that's one of the special right triangles. So let's move on to the next one. Okay, and if you guys need extra practice with this, I'm gonna have a review sheet in the comments so that you guys can go through that. Okay, so this next one is called a 30, 60, 90 right triangle. Again, this is a right triangle, but this one, watch how I draw it a little more different compared to the other one. So this is how this one looks. I'm just gonna draw the other one as like a comparison. Actually, I think this one shows it 30, 60, 90 better than this one. Okay. So aside from my drawing skills that aren't that good, we'll say this one's the 30, 60, 90 because I think it represents it better. And this one is the 45, 45, 90. So as we can see when we're comparing these two, they both have that right angle that we're talking about. That's what gives them that like 90 component right here. But when comparing the other angles of these triangles, we see in this 45, 45, 90, this angle right here, which we'll write as x, and this angle right here, which we'll write as x, they have equal, they're like equal angle measure as each other. And we were able to prove that. This one was 45, this one was 45. But in this 30, 60, 90 triangle, there's like a bit more differentiation, you could say. Right here, I would say is the smaller angle, and then right here is the bit longer angle, you could say. So in a like you can be given a problem, like we're given a right triangle, and then we know one of the angles is 30 degrees. How would we find like the hypotenuse or something like that? You guys could be given a problem like that, and we would first need to be like, okay, what do we know? This is a 30. There's a 30 degree right here. There's a 90 degree right here. What could this angle be? So we have to know. And if we add all these up, by the way, it's equal to 180. So we have to know our that property that all triangles add up to 180. Okay. The next thing you guys need to know about the 30, 60, 90 triangle is again the side property, the sides property, and like what each component of the sides are. So I'm gonna write this is 90 degrees. We know this is 60 degrees, and we know this is 30 degrees. Okay. So this one is, I think, just comes down to memorization. So across the 90 degrees, remember the hypotenuse, and these two are still the legs. Across the hypotenuse, across the 90 degrees in the hypotenuse, this side length is going to be 2x. So it's 2 times the x value we have. And then across from this 30 is going to be x. And across from the 60 is going to be x root 3. All right, so these numbers are a bit, I know, a little bit random, but like here's how I like to remember it. So hypotenuse is like the longest side, so it's gonna be 2 times whatever value is the smaller one, and then the 60 degrees is just a bigger number compared to 30, and then root 3 is a bigger number than the 1 that's right here. So I like to think, okay, so 60 is bigger, so that goes with the other bigger number of square root of 3. So that's how I like to remember it, but it just comes down to memorization for that, for 30, 60, 90 triangles. Okay, so I'm going to go over some practice, and then again, if you need more practice, you can go over the review sheet if you need. So yeah, let's do 3 practice problems here. Okay, so if one leg is 7 centimeters, what is the hypotenuse? Alright, let me make that bigger. And then we're gonna be given this triangle just like as a drawing. So we're given this triangle right here, and then this is gonna be known as right angle, and we're given that this angle right here is 45 degrees. So you guys can pause the video. How do you think you would solve this? Okay, So what you would do is, what I like to do first is write down, okay, we have 45 and we have a 90. So 45 plus something, this angle we'll write as x, plus 90 equals 180. Well, we know if we see a 45, we said 90, so that makes me assume that right here is a 45. So we have a 45, 45, 90 triangle. Okay, now let's go back to our memorization of 45, 45, 90 triangles. What do each of the 45, 45, 90 angles have like their side relations? So remember, 45, across from the 45 is x. So across both these 45 is going to be a side of x. And then across the right angle here, we're going to have x root 2. Okay, and we're told that one leg is 7 centimeters. So remember, these sides right here are known as the legs. So x is equal to 7. So that means this value is also equal to 7. And we're told what is the hypotenuse. So easy way we can solve this is just by plugging in that x we know. So then we know the hypotenuse, I'll just write h is equal to 7 square root of 2. So we know the hypotenuse is that for this problem. Okay, let's move on to our second example here. Okay, if the short leg equals 5 centimeters, I'll find the other two sides. Okay, so, and we're going to be given this triangle right here. I'm going to draw it out. Something like that. And we have a right angle right here. And we're also given that this right here is 30 degrees. Okay, so what I see is that I see a 90-degree angle and I see a 30-degree angle. So 90 plus 30, we know that's 120. And we'll just label this as x, our missing angle, plus x is equal to 180. Now we can just do some simple algebra, and we know that x is equal to 60. So we found that this is 60, and we know now that this is a 30, 60, 90 triangle. You guys can't always assume that a triangle is 30, 60, 90 or 45, 45, 90 unless it's explicitly given to you, or you can solve for one of the angles. If you assume that it might be like, instead of 30 and 60, it might be like 29 instead of 30, or like 59 instead of 60. You guys should never assume that unless it says. So now that we know it's the 30, 60, 90 triangle, we proved it. Let's find out the other side. So we know the short leg is 5 centimeters. So we know that the short leg, remember 30 is a smaller number, so the smaller number is going to be here. So we know that this is x, and then across the 60 is x root 3. And we know the biggest number, 2x, is the bigger side of the triangle of the hypotenuse. So we know that the short leg is 5 centimeters. I'm just going to write 5. So let's find the other two sides. So we can plug in x into here, and we can plug in x into here. So we know that the longer leg can just be 5 root 3, and we know that the hypotenuse can be 2 times 5, and that's just simply equal to 10. So we found that the long leg side length is 5 root 3 centimeters, and we found that the hypotenuse length is 10 centimeters. Alright, moving on to our last question. And this one's going to be a word problem. You guys might see some word problems with these type of questions. So a ladder makes a 60-degree angle with the ground and reaches a wall 10 feet high. How long is the ladder? Alright, let me make this question bigger. Okay, so this is our question. So this one, we're not provided an initial triangle or anything. We're just given a scenario. So what I like to do is draw out, okay, what's their scenario? So a ladder makes a 60-degree angle, I'm going to underline that, with the ground and reaches a wall 10 feet high. So let's draw a wall right here. And then we're given a ladder, and it's leaning against that wall. And the ground is, let me draw a better ladder there. and then is leaning against the wall, and then on the ground is right there. So let's connect this right here. And that gives us the ground. This is the ground right here, and this is the wall. Okay, so we know the ladder makes a 60-degree angle with the ground. So that means this value right here is 60 degrees. And we can see right here, this is a 90-degree angle because these two lines intersect perpendicularly. So this is a 90-degree angle. So I see a 60-degree angle, I see a 90-degree angle. So 90 plus 60 is 150, and then 180 minus 150 is 30. So this one right here is a 30-degree angle. And we're also told that the ladder reaches a wall 10 feet high. So we know the wall, this wall right here, is 10 feet high. So let's go back to our components of a 30, 60, 90. We remember that 30 is the shortest because it's x, and then 90 is the longest and it's the hypotenuse, so it's 2x, and 2 is the larger number, and then 60 is right here, x root 3. Okay, we're told that this wall is 10 feet, so in order to solve for x, we actually have to do some algebra here. So 10 is equal to x root 3. We need to solve for that x value. That'll help us find the other parts of the problem. So let's divide root 3 here. Divide root 3 to both sides. And we find that x, with a little bit of rationalization, is equal to 10 root 3 over 3. Or you can just leave it as 10 divided by a square root of 3 equals x. Okay, so now we know that x is equal to that. Now our goal is to find how long the ladder is. We know that this whole thing right here is the ladder. So what we have to do is just plug in this x value that we found into this part right here. So all we do is 2 times this value right here, and that gives us 20 square root 3 over 3. Alright, so that's it for today's video. If you guys need more practice, again, there's going to be the worksheet in the comments. And yeah, thank you so much.